Sveiki visi. Šiandien susitinkame jau 26-ame Tribe of AI ir antrajame kartu su Artificial Intelligence of Lithuania meetup. So today we are going to talk, have a panel discussion beyond modeling, data engineering, model serving, and other parts of production machine learning system. I'm super happy to have guests today, the members of the panel discussion. So let's meet them. So we have Mindaugas Iglinskas. We also have Karolis Uziela and Mantas Puida. Hopefully you know all of them. All of them are significant members of our artificial intelligence community in Lithuania, and I'm super happy to have them on board in this discussion today. But before we proceed with the discussion, let's have a few updates. So first of all, I want to say hi. For those who don't know me, I am Dovydas. I am somewhat involved in 4 organizations. All of the involvement is very, very closely related to artificial intelligence. And so I am the president of Artificial Intelligence Association of Lithuania. I'm also machine learning team lead at Vinted, data team lead at Turing College, and also founder of Tribe of AI. Then let me present the plan for today. So first of all, some community updates. Then we are going to do the panel discussion. Finally, time for your questions. And it's not true networking, but if you have some questions for the speakers, or if you have some questions which you just want to talk about in the comments, you can go ahead and do that. By the way, you have we are expecting your questions for the panel discussion. So please post them at this link which you see at the top of your screen. So use this link to post your questions, and I'll try to get them answered during the discussion. So now let's proceed with the community updates. We have done quite a few interesting things, and first of them is this meetup. So it's the second joint meetup by Artificial Intelligence Association of Lithuania and also Tribe of AI. Super happy that this collaboration continues to work, and both of the organizations bring their members and bring their joint efforts to make these meetups happen. The second thing regarding the Artificial Intelligence Association of Lithuania is that we are doing quite a few changes. So first of all, we are going to make Slack, our Slack for members only. So we have our Slack currently is open, but we are transitioning to members only Slack. So that should give you a much more trustworthy and much more experienced members, and overall better experience. We can have finally the premium version of Slack, because we wouldn't have so many members who are just there and not contributing to any projects. Also, second thing is we are finally making strides in making the list of association members public. So I quickly want to share, I'll make an official announcement later, but we already have some work in progress right here. And as you can see our full list of members. Not everybody has their photo uploaded yet, so if you are a member, please fill the form. We have posted the form on Slack. Please fill the form, and you will be updated, and your photo and your information will be here on our public members list. It's not fully integrated into our website, so just sharing this kind of work in progress list, and we expect to have it fully production ready in like before the next meetup. Also, we have amazing things such as search. So if you are interested in, I don't know, just board members, you can filter them out. If you're interested in some like specific topics, so for example, presentations. So I'm the only one who is interested in presentations, maybe teaching. So more people interested in teaching. So it's very, very convenient. You can search people by their interests. You can search people by their companies. You can pretty much have an actionable actionable members list of our association. So very happy with this progress. Finally, we are trying very hard to involve all members in participation in the projects which we do as association. So expect that since our Slack becomes members only, we are going to try to involve you much more into the key decisions which we are making as association. If you're consulting some government agencies, or if you're working with just other associations or other institutions, we are going to ask your help, and maybe you are the expert in this thing. So we really, really want to hear from you if you're a member. As I mentioned, our communication is going to happen on Slack. So this is pretty much Slack is going to get amazing, and all of the information is this members only information is going to be there. So finally, if you are interested in becoming a member with all of these new exciting things happening, so you can do it, you can follow this link. By the way, I'll post the presentation on, I post the slides on Tribe of AI, and I'll also post it on Slack, and I'll try to post it on our Facebook as well. So you'll find all the links to this, to becoming a member, and also to this presentation after the presentation later today. A few more updates. So one from Tribe of AI. We are looking to expand the AI Academy, and to do that, we are looking for mentors. So if you are interested in just spending just a little bit of time, quite not a lot of time commitment, about 2-3 hours per week, and have your own team of machine learning or artificial intelligence learners, which you can help and to guide through the process of becoming an AI expert. So if you are interested in helping them out, please contact me, fill this form, and I'll try to make it happen that you have a team of capable, smart students who are looking to become AI experts. Finally, Turing College is launching their data science course quite soon. So that's the spiritual successor to the AI Bootcamp. AI Bootcamp 2.0 was planned to start this year, but data science course from Turing College takes the mantle. And if you are interested in becoming an AI expert or data science expert in this regard, quite fast with more support, so please check out this course. I think it's going to be pretty amazing experience. Finally, let's move to the main topic for today, the panel discussion, beyond modeling, data engineering, model serving, and other parts of the AI production system. So I'm going to switch back so you see all members. So if you don't have the slides, the Q&A link yet, I'm going to paste it on YouTube comments, and after we do that, we are going to switch to the view for everybody. So give me a minute to post it. Yep, It's on YouTube now, so you can find it there. Yeah, let me stop the screen sharing. And the first thing which I want to ask all of the participants of the discussion, can you quickly introduce yourself? Can you say like what's like in which company you're currently working, and what do you do there, so that we have like a little bit of context. What's your main expertise, and what questions the listeners can ask you. So first, let's start, Mindaugas, with you.
My name is Mindaugas. I'm CEO at Pixavia. We build software for fully automated stores, and I am a former assistant professor at Vilnius University. So I spent more than 10 years in robotics and neural networks fields.
Right. Thank you, Mindaugas. Karolis?
So hello everyone, I'm Karolis, and I work in neurotechnology, and I am the project lead of Syntheside.ai. So Syntheside.ai is a platform where users can train their own neural networks for image recognition, and we can also use this platform for labeling the data, and it's online platform, so they don't have to be experts in machine learning. So it's, we can use this platform without much knowledge.
Mm-hmm. Thank you. Mantas?
Hi, I'm Mantas. I'm from Unity 3D, the game engine company, and I am working on real-time inference engine, basically making sure that neural nets can run in real time. It could be reinforcement learning agents, it could be 3D graphics, it could be augmented reality related things.
Mm-hmm. Thank you, Mantas. Thanks, the panel. So let's start with like initial topic. Let's make it machine learning and software engineering. So what are the differences, similarities of these types of projects? And maybe, Mindaugas, can you just quickly go over what do you consider to be a machine learning production system?
Okay, first of all, I don't think that we have question machine learning versus software engineering. Most likely, machine learning is a part of software engineering, and in the software engineering, we also have pure differences, like how we build database engine and how we build front-end parts are completely different. So like machine learning is also part of the software engineering. It's a different one, but just we apply the main principles for machine learning, how we, which software we use, how we test. I would not say that we have enormous differences. We have differences, but like similar differences that we have in other software engineering fields. I've talked about machine learning. I know most likely I can talk from my side only. We also combine neural networks models with usual code we have in each system. So it's also very difficult to say when it's say production level machine learning system, it always consists a lot of simple code. But what is production level? Most likely when we have at least 50% of complexity solved by neural networks. In this case, we can say that we have machine learning system. It's very difficult to define, but I will define in this way.
All right. So Mindaugas, back to you. Since you explained that machine learning projects are just part of like this general software engineering field, Maybe you can tell us a little bit more, let's take a typical or traditional software engineering project, like just something like a web service or I don't know, anything else, and machine learning project. So can you elaborate a little bit of what differences did you have you experienced in practice where you built like this neural network based systems versus just systems without the ML component?
I think the main difference is like for traditional software system, the most important part is code. If we talk about machine learning, the most important part most likely is data. I would say in this way. So we have code, which is most important part, and the data. And yes, a lot of in between, but just these parts most likely define what it is, what kind of system we have.
Mm-hmm. Yeah, thanks. Great answer. By the way, Mantas, Karolis, if you have anything to add?
Yeah, I would like to add that machine learning is kind of different in the sense that when you start machine learning project, you never know if you will be able to achieve final goal. With usual software engineering project, you know that somebody already achieved similar goal, right? So if you need accuracy of 99% in real-time environment, in real world, you might not be able to achieve in like 5 years or 7 years, right? That might be challenging. On the other hand, if you have machine learning product which interacts with human, then you also should not forget about manual QA, user acceptance testing, and in overall user experience, how this machine learning product will interact with humans, how humans will react to that, which is kind of same thing as for a regular software project, but maybe many machine learning people are forgetting about that. At least I see that sometimes happen.
Oh, it's very interesting, super interesting that you touched the topic of not knowing if the model is going to be actually usable in production. So can you tell a little bit more, what do you think defines like the success? How could you guess before you starting the project, or what are the like usual suspects that are responsible for the project, for the ML project? Even if you do everything right, it might not reach the accuracy, which is like the minimal acceptable accuracy or something.
The problem is not accuracy here. It's more like how humans react to that level of accuracy, right? Mathematically, it could be like 95%, right? But in this 5%, some are maybe very important to humans. So you need to like stretch a bit of how you evaluate the things. But I think the bigger problem is here that a lot of scientific papers are done in very limited set of data, with a limited set of data. And once you try to go to the wild, you might not encounter the same data. And sometimes it might be hard for you to even collect the data. For example, if you are doing augmented reality from the phone camera, every phone camera has different properties, and it actually captures image with different aberrations, different noise, and your model might be very sensitive to that. And until you capture more data from the real world, you can't tell if your model can even achieve that. Of course, you can start with the synthetic data and say, oh, my model is achieving with synthetic data something, but it still might not generalize to actual real world good enough. I think I see that these problems quite a lot of time.
All right. Yeah. Great answer. Thanks. Karolis, I have the next question is for you. So
maybe I can add something to this question.
Oh yeah, sure. Go for it.
Yeah. Well, I agree with Mantas a lot that estimating the success of the project is very difficult in machine learning projects. And actually, we have sometimes clients who come with their own image recognition problem. And so we sometimes offer them to do a custom solution. But for us, it's the most difficult part evaluate what could be the accuracy of this solution and whether it's going to be sufficient for the client. So the way we solve it is often we, first of all, we always ask for sample images to see the actual data, because just from seeing the actual images, it's often, you can often sort of suspect whether the project is could be successful, or you can never say that it's for sure gonna be successful, but you can sometimes say that it's almost impossible. And the second thing is we often offer the clients a pilot project. So we do like a smaller scale pilot experiment with, let's say, less data and less different classes, less complexity, basically. And we see how manageable is this smaller problem, and if our solution is sort of sufficient for the client, and the client is happy with our work, then we proceed with a bigger project.
Right.
So.
Yeah, you actually touched a little bit on my next question, which I also wanted to address for you. So what common mistakes you see when companies start to do or develop machine learning production models?
Yeah, well, apart from what I said, is like from being difficult to evaluate the success of the project. I mean, the mistakes could also be the same mistakes as in software engineering projects. For example, people sometimes try to write the code quickly, copy-pasting the code and repeating themselves, and then we are realizing that we need to do some additional features, and then it becomes much more difficult to add those features. Yeah, another thing is maybe for machine learning, it's very important to think of the scalability from the start, because let's say if you're doing online system and you want to serve the model for many people, you have to think in advance what's going to happen when the user audience will grow, and you'll need basically more GPUs, and you'll need to think how you will serve this model for larger audience.
All right. And Lucas, do you have anything to add to that?
Hard to tell, like we work with some subset of problems, and we don't have like a broad experience with different problems which can face other company. In our case, like our the biggest question and the bigger problem we have, and we have add additional functionality, how fast we can label data, do we will have enough data, and will the customer allow us to get the data? And like the last question most likely is the most important one, like how much paperwork we will need to train our system, not much how much data, but how much paperwork is required to train the system. So like if it work with video feeds, like this part is also super important.
Mm-hmm. Yeah, that's very important topic. How can you go over? I mean, the AI is not it's regulated, but the regulation is pretty new. So sometimes maybe it's a bit much. We are trying to be a little bit too strict. And I don't know, Mantas, Karolis, do you have similar problems that like just being able to get the data with correct, I don't know, agreements or legal stuff?
Absolutely, I agree with Mindaugas that it's probably the largest challenge is to get a sufficient amount of data and to label the data, which sometimes could be also a very resource-consuming task. Yeah, so I would say that these two are the biggest challenge is getting good quality data, and then second one is to evaluate the potential success of the project.
I just wanted to add what Mindaugas was telling, that sometimes it's good to ask if you actually need machine learning in your project at all. I mean, sometimes even the economic aspect might be most important one. If you have only like 200 transactions per month, and they are not very high value, do you actually need to hire a team to build AI for that, right? Sometimes people not thinking that building AI system is very expensive, and that means that you need to use it in the high scale to actually become it as economic thing, like how much you will pay for one transaction done by AI.
Mm-hmm. Yeah, it's very interesting concept of really thinking about business value which your machine learning solution will provide. I would like to get back to more technical things, and what's more technical than technical debt. And maybe you are familiar with the paper Hidden Technical Debt in Machine Learning Systems. At least in my company, it's it was a pretty important paper, which we read and said, yeah, we made lots of these mistakes as well. So maybe you can share what type of technical debt you have, and how do you decide then it's time to pay it off, or how do you like handle technical debt in machine learning systems overall? And I would like to start, Mantas, with you on this question.
Yeah, I think I'm between different camp here, because in the gaming industry, it's like if it's worked, it's good enough. Of course, there might be some technical debt around how easy you can reproduce results, or how easy you can make new version of this AI. But usually, for many games, you made a first version of the game, you ship to the market, and maybe you will release next version in 2 years, but it might be different game at all. So if it was good enough to ship once, maybe it's good enough, right? But it's not typical for business use cases, I guess.
Mm-hmm. Mindaugas, what about you?
I think about two types of technical debt, maybe in general, maybe in our systems. The first one is how efficient or inefficient is your data gathering and labeling process. Because if you do it inefficiently, you don't have enough of data, and even worse, you can have your data quality will be not sufficient to train the system, and if you're doing this again and again, so and you don't fix this debt into your system, so you're adding some waste in your training pipeline. And second one, if you don't have your data quality is not good enough, most likely you're adding some additional filtering on top of it, and also you work with your technical debt, which you most likely have in the first step. Currently, I'm thinking about these two types of debt. Maybe it's not fit the right debt definition, I don't know, but just I'm thinking more in these categories.
Mm-hmm. Yeah, I mean the definition, which at least in the paper we tackled so many different aspects of technical debt. And in addition, they named that there is some hidden technical debt, which is very, very non-obvious, but at the end of the day, you see that your engineers are working all the time and delivering nothing. So there must be some technical debt which we are paying off throughout the day, and it's really difficult to go down and find what's causing all of these things. Carolus, unless you have anything to add to the technical debt, I'd like to move to the next question for you. So, do you?
Well, maybe I would just repeat myself that making the scalable systems is very important in machine learning projects. So if you don't think of the scalability from the start, then you'll have to refactor and perhaps rewrite your code later. For example, we had to do this with the labeling tool because it worked very well for small amounts of images, but then the amount of images grew larger, it started to slow down. And, so these are the things you need to think of in advance.
All right. So the next question is still for you. How would you describe a typical machine learning project workflow?
Yeah, so in the beginning, of course, you need to collect data to get good quality data, and it depends what kind of data it is. You might need to pre-process it, filter it, sometimes even manually. Then the next step, I would say, should be exploratory data analysis, or if the data is numeric data, then you would plot some maybe scatter plots, some histograms, and so on. Then you would need, based on this, on the data you observed and on the exploratory analysis, you would need to select the architecture for your algorithm or the neural network. You can do this several ways. You can either choose one architecture that you think is going to be successful, or you can try several algorithms, several architectures, and basically train them in parallel. So then, of course, you need to train the model, to evaluate its performance on various metrics, to fine-tune hyperparameters of the model, and perhaps to select the best hyperparameters and the best architecture from the ones you tried. Then you would need, once you have this trained model, you would need to optimize the speed for model serving. So, for example, you could use TensorRT SDK which optimizes the performance on CPU a lot, especially on platforms like Jetson. But it also optimizes slightly performance on GPU. Then you would need to deploy the model. So if the model is going to be deployed on the web, then it's probably the best to deploy it via REST API, which is sort of HTTP protocol for sending requests and getting responses. So request would be well, in our case, it's the image, and the response is the prediction for this image. Then, depending on the amount of users who are using it, again, you have to make it scalable. Perhaps you would need to containerize the model. So you could use something like a Kubernetes cluster, which uses Docker containers, and well, it could make the model serving more scalable. And of course, you need to write integration tests for this model, and to write documentation. And after you complete this whole cycle, you can basically just repeat from the start. Again, you can either gather more data, you can do again exploratory analysis and train different models with different architectures to improve your whole pipeline.
Yeah, very amazing answer, Karolis. Thank you. Quite in depth. Mindaugas, Mantas, do you have anything to add to that?
I think the whole roadmap was very well and detailed described, most likely it fit for all, at least imaging tasks.
Yeah, I see the connection with one of the first questions, how did the software engineering and machine learning projects differ. I see there in machine learning projects, we have very large research phase and also development phase, while in software projects, usually research phase is very small and sometimes maybe none, and then you have huge development phase. So I think in this machine learning projects, it's very important to have this. A lot of exploratory research before you actually start developing things, because sometimes you might do wrong decisions very early, and then it would be hard to fix it later if you start developing project like as a software too early.
I think I would disagree in this case because here most likely we talk about research. We solve sometimes very similar problems in two different ways, by using neural networks and also by writing just code. Like, for example, multi-object tracking from multiple cameras can be solved in both ways. Currently, our approach, how we combine information from different cameras is just by written code, but like here there is also huge research going, like how we combine models, how which statistical properties is required, calculate when we are combining different points from different cameras. So I think it depends on project. Here, when we have like neural networks, most likely we have some difficult problems to solve, but also very difficult problems exist in, let's say, usual software engineering.
Thanks for addition, Mindaugas. Actually, the next question is for you. But before we do that, I would like to check if you have any questions from the audience, so I can add them in. Give me a minute. I don't see any questions yet, so if you have questions regarding what we are talking about, please post them on our Google Slides Q&A. You'll find the link in the YouTube comment. And let's get back to my question. So the next question from me is regarding data engineering. And let's talk about how to provide data for training the machine learning models. And Mindaugas, this question is for you. How do you do that in your company?
Okay, like I think it's super easy question. You gather a lot of data, you label them, you check the quality of data. Most likely in our case, it's mainly images, and you train your selected neural network model. Most likely you have already. I don't know, like here, and when you have images and already more or less prepared pipelines, it's very difficult to go into some, maybe rather some deep differences, but here, like I would say, it's a simple answer.
Right. Anybody has more problems that I know we have? I wouldn't call them problems, but I would call them challenges in our company regarding providing the data to machine learning models. But maybe Karolis, Mantas, do you have anything to add to what Mindaugas said?
Sorry, what was the original question?
The question is providing data for training machine learning models. Do you have any challenges with that? And if you do, so can you elaborate on how you're solving them?
No, I think I agree with Mindaugas that it is basically a quite straightforward question. You just need to collect data and to assure that it's good quality and to label the data. That are the biggest challenges.
I would like to add that for visual data, it's usually a bit problematic from technical side how to deliver gigabytes or sometimes terabytes of data to your training machines and how to distribute that. And it's becoming quite challenging if you have a lot of data. And another interesting topic is if you're doing reinforcement learning and you're doing a generation of the simulation data. Basically, your agent is training in simulated environment. In this case, you kind of don't have data ahead of time. You might save some, but not all reinforcement learning algorithms allow you to reuse data easily from different policy experiences. But in this case, you need to balance how quickly your training machines can do the backpropagation and how quickly your simulation machines can produce the data. Basically, you have the loop, you produce some neural net and that does some decisions. Then you run it through the simulations, get the feedback from the environment, train another version of the brain of the agent, right? And if your training is faster than simulation, you're kind of losing some time and probably money. And if your simulation is faster than training, then you're also losing some money. So balancing these two parts is pretty challenging.
Yeah, thanks, Mantas, for addition. My second question regarding the data, and it also depends if you're doing this thing or if you're not, is about data versioning. Do you have versions of your data sets or models which were trained on this version of the data set? Because at least for me, the data set evolves and becomes outdated. So it's nice to know on which data set it was trained on, so the next iterations can take that into account, or we can know that if something starts to get wrong, maybe we should also check the data and what kind of model was trained on this data. So maybe Karolis, I'm not sure if you're doing these types of things.
Well, in our case, the data is images in Synthesize platform, so you can't really do versioning like in text data or numeric data. So the versioning we do is basically we just save the images on which the model was trained. So for each model, we just save all the images for which it was trained, just in case we need to rerun the training code to find what went wrong.
All right. So anybody wants to add to that?
I think same applies to us. At least we have the latest version, like the biggest training set, and in most cases we just use as much data as possible to train the new neural networks, new neural network, and as I see, in almost all cases, it performs better. It's almost like at least we don't have like a real versioning of data right now.
Right. So let's move to the next topic: deploying machine learnings to production. And so this one there are like so many articles written about most of the models actually not leaving the notebooks in which they were developed, and companies unable to deploy anything machine learning to production. I guess this part and for us was quite challenging, and we were investing quite a bit of time and resources into making the deployment easier. So could you tell me a little bit about your deployment procedure? I know that Karolis mentioned it a little bit on his the full workflow analysis. So maybe Mantas, can you tell us about how you do these things?
Yeah, I usually start with the question, where will run the neural nets or like machine learning models? Will it be on the edge, on the device of the user? Will it be on the cloud? Because sometimes it also depends a lot of business case. Basically, if you would like to run everything on the cloud, it might be super expensive if you're doing some image transformation tasks, not recognition, but something more complicated. Right, and then like if you have 1 million of active users per month, it might burn several millions per month of the money, right? How then you monetize these users? That's the big question. And once you have like target platform where you will run the model, then you start thinking what is the best performing framework on that platform. Because, well, TensorFlow probably works well with the NVIDIA cards, right? But what if you need to run it on the Intel GPU, right? Or maybe on the CPU? Well, TensorFlow might be good, but if you need to run it on the iOS device or Android device, right? On Android device, probably you want to run with neural net API and then API. And it supports only limited set of the operators. So maybe your researchers added a lot of crazy operators to the model and it performs well in your notebook. Then you need another team of people who will grab that model, tune it to the smaller thing to run it perfectly on the mobile device. Also remove unnecessary operations which don't contribute to actual accuracy of the model, and basically make things happen. And you should stop thinking that the framework you used to train the model or like do the research will be the same which one you will be using to do the inference in the final like production deployment. That's my take on that.
All right, thanks. Mindaugas, do you have anything to add to that?
In our case, I would say we have a rather simple approach. Most of our models are trained on PyTorch, and normally we export the model to TensorRT and run into container on TensorRT. And this is the main approach we have with our models.
Right. Do you have anything like automated pipelines which do that for you? I mean, the retraining of the model, or like containerizing, some CI/CD pipelines which do these things for you?
No, at least not yet. We made some steps to automate part of the jobs, but still, currently it's still manual process to train, to test, and to deploy the model into TensorRT and to launch TensorRT into container. Like it's standardized, but still a lot of manual work is required for each step.
All right, Karolis, do you want, since you had mentioned it a little bit, do you have anything else to add?
Well, I think nothing important. Well, maybe, we just recently found a good way to serve the models. So we right now use Flask with waitress package. So maybe it's kind of possible for somebody, because before we used different libraries and it was not as stable as it's right now.
Mm-hmm. Could you elaborate? To be honest, I'm personally very interested in you're using waitress package, right?
Yes.
So what benefit does it bring you?
We just use waitress because it was sort of the easiest to implement with Flask package. But before we were not using Flask, we were just using HTTP libraries, and there was problems that the service was running and it would sometimes randomly stopped after maybe 4 or 5 days of running. So and now it seems to be better.
Right. We had some 2 Mindaugas joining somehow, but I see it's fixed now.
I'll just reload it. Sorry.
Oh, it's okay. I would like to go back to what Mantas mentioned previously about deciding to run on cloud or on the edge. Just not everybody is using the cloud, so I would prefer to call it on the server or versus on the device. But sure, it's kind of running the models on the cloud is so prevalent that it's kind of becoming the standard to assume that if they are running not on device, it's going to happen on the cloud. I would like to, Mindaugas, and I guess Mantas told what his criteria are for choosing. How would you monetize the users if these image transformations is taking so much server resources that they are costing you millions? I would like to ask the rest of you, so Mindaugas and Karolis, how do you do this thing? Do you have anything running on the edge? And if so, even if you don't, what would be the criteria when you would consider that? So first, Karolis, let's start with you here.
Sure. Well, we have we had one client who wanted to run models on Jetson Nano, and so we just
Karolis, can you
yeah.
maybe shortly elaborate what is a Jetson Nano? What is it a CPU device? Is it a GPU device? And yeah, why did we have this requirement?
Yeah, sure. So Jetson Nano is a CPU device, and it has ARM architecture. So it's a very low-powered device, but it's sort of built for running neural networks, and it's slightly optimized for this. So it's probably the lowest power device which is optimized for running neural networks, the one that I know. And yeah, so what we did is we compiled the model with TensorRT, and it seemed to perform quite well. Yeah, the criteria when I would choose to use the edge devices and when not. So the criteria is actually the complexity of the problem and the speed that you want to get the response. So if the problem is very complex, then probably running it on a low-power device is not going to be a good solution, because you need a complex model. So you probably need a large architecture, and a low-power device will not be able to run this architecture. So in this case, it would be better to run the network on a device with a GPU on a server, and then just to make REST API calls via the network to get the predictions on this low power device, if you still want to use low power device. On the other hand, if the problem is not very complex, or maybe you don't need fast response time, you could wait a few seconds to get a response, then you could deploy the model right on this edge device. So the advantage would be that you don't need the network for this device, and this could be, I don't know, some autonomous vehicle, or maybe a drone or something which have problems to have a stable network connection. So in this case, you need to, of course, to run it on edge devices.
Yeah, I imagined the self-driving car, which sends everything to the cloud, and if it goes to a tunnel, loses the self-driving capabilities. Would be absurd, of course. Yeah, Mindaugas, do you have anything to add to that?
We run everything on the edge, but I would say we have two levels of edginess. We have powerful GPUs in the store, but at the same time we have the same Jetson Nanos on each shelf. So we have two levels for Jetson Nanos to process signals from the sensors, and powerful GPUs to process incoming video feeds from each camera. But at least right now, we process all images on the edge in the store, mainly because of two reasons. One, it's more effective and it's cheaper to do compared to Amazon Cloud. When you have to send millions of bytes each second, it will be super expensive. Second thing, the same GDPR compliance, that you should do everything as possible near the camera and destroy images from your memory as fast as possible. So normally we take image, we extract all the data, and we erase image instantly. So and it will be very more difficult to do the same when you pass your image through public networks. So main two things why we do this everything on the edge, but we have two levels of, as we mentioned, edginess. Don't know how to say.
All right. Yeah, it's very interesting, to learn more about how these things are actually happening in practice. I guess most people don't have anything deployed in production, so it's really interesting, to learn from the cases how you solve these problems for your specific business case. And I see that we are actually almost at the end of our meeting. Let me finally check if you have any questions so that we can answer those. Yeah, we have actually quite a few questions. Let me start with the first one. How does testing and CI/CD differ when working with machine learning models? Should tests include the accuracy metrics? And anybody wants to volunteer to answer this question?
Well, I can try to answer. So the way we do it in Syntheside, we do test the accuracy of model training, and the problem is that model training is a stochastic process. We can try to set fixed random seeds to make it not stochastic, but still in our experience that the results slightly differ. So we just accept that, and we test. We still test the accuracy of the trained model. We just have some level of how to say, of tolerance. So we have, so if the accuracy is not much larger or not much lower than the expected one, when the test passes. And in rare cases, if the test fails, we can just check, and if we see that the accuracy is still somewhat close, we just basically discard this test, and this is how it works in our case.
Very cool answer. Actually, it reminded me that For those of you who are not familiar with this fact, it's impossible to have deterministic model training on GPUs. And it's actually only possible if you're using single processes on CPUs as well, so no multiprocessing. Turns out it's to have completely deterministic results every single time is really, really not trivial and, of course, impractical. Let's move to the next question. So Bodus asks, what kind of open source model serving tools, or not necessarily open source, but what kind of model serving tools, products do you use in your production environments? I guess it's pretty interesting to ask all of you that. I know that Karolis already mentioned Flask and Waitress. Maybe Mindaugas, can you share your how you do these things?
Like, can you describe model? What kind of tools?
So just how do you do your like serving? Are you using Flask? Are you using TensorFlow Extended or something? How do you basically, how the inference happens?
Everything runs in our case on TensorRT. I'm not sure it's open source. We train on PyTorch or TensorFlow with an open source model, but most likely we don't use a lot of different tooling for this.
All right. Mantas, what about you?
Yeah, so, well, we kind of use Onyx format for interchange between different frameworks. And we have custom inference engine. So basically you train with PyTorch or TensorFlow, then convert to Onyx. And then we are loading that into our custom format and running natively on each platform, what that platform supports. It might be a neural net API on Android. It could be just plain CPU implementation or compute shaders on GPU on specific platform.
Yeah, I guess this is for you. In your case, it would be a separate presentation. Super interesting how you guys do that.
Yeah, that's with our kind of use case is different. We need to run on all platforms, including like PlayStation, Xbox, and similar things where you can't even properly compile TensorFlow for that platform.
Mm-hmm. By the way, just follow up from me. How do you find Onyx format? Did you have any issues with it, and has it improved in their performance?
Well, the performance, it depends a lot of your importing framework, how well it imports into your framework, right? And I think it's pretty well improving. It actually removes a lot of noise, for us at least, which each separate framework adds and every researcher is adding. But it makes life harder to export to Onyx. But if you pass that kind of challenge, then it's actually giving you benefits. Your model is becoming more well laid, as I would say, like well structured, etc.
All right, great answer. Thanks, Pontus. Let's get back to more questions. Linus asks, fast forward a decade, then maybe some of machine learning building could be streamlined, and also there could be some user-friendly tools like Tableau for reporting. Would ML development part in mid-large companies fall more into data analyst, scientist portfolio, or engineers, or lines would blur? So pretty philosophical question from Linus. Anybody wants to talk about it?
Well, I can try to talk about it. So I think in a way, yes, because there are already tools that make training machine learning models much easier. Well, not mention our own tool, but it's only for images, but there are also many tools for different types of data. For example, I just randomly recently found out that my ex-classmate from Vilnius University, now works in Copenhagen in a company which makes a product called Data Robot. And this data robot is exactly what Linus has described. It's aimed for data analysts for training neural networks in a very simple way and analyzing the data just basically on a web platform. And in a way, I think this will be a big part of it, but I think still in the future will be a need for hardcore ML engineers, and some companies would have ML engineers that develop their models, maybe because we need more complex models which are not covered by these standard tools, whereas other companies which have maybe fewer employees and we cannot afford many people working. In all companies, I guess, will have more people working in data analysis field. But if the company, I don't know, let's say produces food, maybe, and it's a small company, maybe it doesn't have a whole department of AI specialists. So these tools will for sure become more prevalent, which helps for people to train neural networks on any other machine learning models in a more user-friendly way.
Right, thanks for elaboration, Karolis. Let's move to the next question. What is more important when using a model, the speed to process or the accuracy? I guess very specific question. We would need more details on that, Anonymous. So if you could post them, we'll answer this question. Let's move to the next one. Do you use cloud or local machines to do the training of deep learning models? Which one would you recommend for startups? Use the cloud or build machine learning or build a machine for deep learning? I know that Mindaugas talked a little bit about the inference part, so maybe Mindaugas, we can go back to you for the training part. Do you use the cloud for training, or do you have your own machines for that?
Okay, like in this case, we have similar approach. I think 80% of our models are trained on our own machines and in our office, and we have several machines in cloud, but somehow people prefer to use own GPUs and like machines which are in office to train the models. Even we have some machines in cloud available. So like our main approach to use own GPUs which are available on the server and own machines.
All right. Mantas, what about you?
Yeah, I also prefer local machines because you can start more quickly with that. Also, you don't have this attachment that, oh, I forgot my VM spinning and it's now eating my money, right? And that's a bit of problem. And another thing that cloud starts to make sense once you have multi-GPU training, but to achieve that, you need to put a lot of effort, and not for every model it comes easily. On the other hand, for startups, Google Cloud and I think Amazon are giving free credits. So it might be like easier to start with zero funding. If you don't have any funding, right? You grab these credits for startups and start using the cloud for free. But if you have some money, building local machine probably is more preferable. At least if your models are not huge. If they don't fit in single GPU, then you have a problem with local machine.
The new 3090 GPUs are pretty amazing because we have so much memory now.
That's my hope to get one.
Yep. Yeah, same here. I guess we were super excited when memory was significantly improved in the next iteration of GPUs. I mean, these consumer grade GPUs. Karolis, what about you? How do you do these things?
We actually use both. So if we have we have local resources. We train the models locally on our GPUs. However, if many users want to train models and we don't have enough local GPUs, we start using Amazon GPUs so that the users don't have to wait. And I was just slightly smiling because the scenario where some instances are left running on Amazon happened to us in the beginning when we started to use AWS. So the person who was responsible for this cloud went on holiday, and where some bugs happened. So for more than a week, several instances were just running and counting our money.
Yeah. By the way, did you solve this problem? Do you have like somehow a solution right now to stop the idle GPUs or idle virtual machines?
Right now we just solved those bugs that produce these idle machines, and also from time to time we just log into AWS and we see if there's no idle instances running. But we actually don't have automatic solution for this yet.
Yes, thanks for sharing. Let's move to the last question for today. This is the question regarding the performance. So are there any tips on deploying the models without worrying about the performance? So maybe we can like change this question or refactor the question a little bit to what are your performance tips for deploying the model? How do you make sure that it's as efficient as it can be? And I guess we talked a little bit about it, but maybe you have some other tips. Let's start, yes, Carlos, let's start with you now.
Okay. I'm not sure if I understand the question correctly. So I think I basically already told mostly what we do for the deployment, and yeah. So if you use REST API, let's say Flask or something, then I think pretty much that's the best way to ensure the good performance of your models. Well, REST API is important because the models are loaded on the memory, and every time the user wants to make a request, you don't have to load the model. I guess that's sort of important part for the performance.
We also found that warming up the service is also a good idea. So that the initial request is
one request, yes.
Yeah.
Sure.
I guess
I could add something. Yeah. So basically, if you are running inference on GPU, you need to run them in batches if you want to utilize GPU properly. Which means that you need to collect a couple of incoming requests, make a batch, and then run inference on batch as a whole, because it better utilizes multi-threading in the GPU. Another thing is make sure that you are using framework which supports fusing the activations with the layers. Basically, if you have like convolutional layer and some ReLU activation, if your framework can fuse them into single operation, like single layer, that helps a lot with the performance. Also, you always need to investigate if you have any layers that don't make sense or like just shuffle data back and forth. And a lot of frameworks can't optimize that properly. There already are some optimization compilers from the various frameworks. You might try these to optimize your model. And another thing is that I think that's a good start. Also, you can use profilers. NVIDIA gives you profiler for GPU, which might allow you to see how many milliseconds you're spending on each layer of the network. Of course, if it uses a lot of stuff, you might see bigger blobs than you would see in your source model. But yeah, use profilers when possible.
All right. Yeah. Thanks. Quite an extensive list. Lucas, do you have anything to add?
I don't think I think fundamentally use smaller models. Maybe it sounds stupid, but it's sometimes enough just to have smallest REST net can solve your task also. And I think but other things, use the latest models, the latest algorithms for your task. Also a bit stupid example, YOLO 4 most likely is more efficient than YOLO 1. Just two fundamental things, use the latest algorithms and smallest models. That's it. And yes, apply all possible tuning things like batching and other things.
Yeah. I think amazing insight from Lucas. What we found in practice is that machine learning engineers somehow always want to use the biggest model there is, and we are like actively trying to see like, let's use the smallest model suitable for this problem and see if we get like the accuracy or whatever the performance metric which we choose to track, which is good enough for the initial version, and maybe like later we can investigate if using like EfficientNet V7 is the best way, or maybe the smallest one is like almost as good for this particular case. So I'd like to thank all of the participants today. It was great having you here. I hope that it was important for you as well, that maybe you learned something from your fellow participants. And yeah, thank you all listeners. See you next month in our next Artificial Intelligence Association and Tribe of AI meetup. Bye-bye.
Thank you. Bye.